Okay, I'm going to go ahead and work through these last three on the front page. This next one says how much heat would be lost when 45 grams of lead is cooled from 38 to 20 degrees. So notice right here from 38, so there's my initial temperature, to 20 degrees, there's that final temperature. Here's my mass, and then I'm looking for how much heat would be lost. So it means that I'm looking for Q, and I need to figure out, look at that table for the specific heat of lead. So let's go ahead and fill in what we do know. We know that Q is what we're looking for. I actually know that it's going to end up being a negative Q because it says heat is being lost here. And my mass is 45 grams of lead. Now remember, on the specific heat of lead in this situation, when we look over here, lead is 1.3 times 10 to the 2, but notice that the units are in kilograms. And if the specific heat is given to you in kilograms, that means you need to change your mass to be representative of kilograms as well. So instead of writing 45 grams in here, I'm going to move my decimal 3 places to the right, and I'm going to put in 0.0450 kilograms times, again, looking at lead, the specific heat of lead, 1.3 times 10 to the 2, so that would be 130. And those units are joules per kilogram degrees Celsius, times final temperature is 20, minus initial temperature would be negative 18 degrees Celsius. And you see that temperature change is what makes the Q positive or negative. And so from here, all we have to do is put it into our calculator. Do that real quick. And we get negative 105.3 joules. Now again, pay attention to your significant figures. 3 sig figs, 3 sig figs, 3 sig figs. So our answer should be in 3 sig figs, which means our final answer should be negative 105 joules for this one. Just to kind of go ahead and start practicing this, would that be considered an endo or an exothermic reaction? Well, since the Q is negative, energy is being lost, which means this right here would be considered an exothermic reaction. So in those two, you've seen how to calculate Q. Let's take a look at where we're calculating some specific heats down here. This one says determine the specific heat, and I see right here the units that it wants it in, of a material if 12 gram sample absorbs 28 joules. So since it's being absorbed, it's a positive 28 joules. As it's heated from 20, there's that initial temperature, to 40, there's that final temperature. So 28.0 joules is my Q, equals the mass is 12.0 grams times specific heat is what I'm looking for, so I'm going to leave it alone. And then my delta T, final 40 minus 20, would be 20.0 degrees Celsius. So from here, especially my math people, if you're weak in math, combine these two like terms. 12 times 20 is going to give me 240. So I've got 28.0 joules equals 240 grams degrees Celsius times CP. Again, I'm trying to solve for that specific heat. So how do I get that by itself? Well, I'm going to divide both sides by 240. And then 28 divided by 240 is going to give me 0.117. Okay. Specific, I'm looking at sig figs, 3 sig figs, 3 sig figs, 3. So I've got it in the correct number of significant figures. And as far as units go, that is going to be joules per gram degrees Celsius. Again, that's my specific heat right there. So just solving for a variable on that one. And let's do one more on this video. Again, this would be considered endothermic because I'd already been able to see that energy was absorbed, which makes it endothermic. A 4 gram sample of glass was heated from 0 to 41, was found to absorb 32 joules of heat. And again, it's looking for the specific heat. So let's plug in what we know. We know that we've got 32.0 joules of heat is absorbed. The mass is 4.00 grams. I'm looking for the specific heat, so I'm going to leave that alone. 0 is my initial temp, 241. So actually the temperature change here is 41.0 degrees Celsius. Same thing as last time. You're going to combine like terms. So 4 times 41. And that's going to give me 164. So I've got 32.0 joules equals 164 grams degrees Celsius times CP. How do I get the the CP by itself? Divide both sides by 164. And so then we've got 32 divided by 164, and that is going to give us 0.195. 3 sig figs, 3 sig figs, 3 sig figs. So everything's 3 sig figs, and again, that would be joules per gram degrees Celsius. So there's that other specific heat. Again, that's an endothermic reaction because energy is being absorbed. Okay, guys, I'm going to go outside and play in the snow. I will come back in and work through some more of those practice.